Hello and welcome to this production Rust course on how to build a GraphQL server. Now, like all production Rust courses, this is going to be very hands-on, very practical. You're going to see me code live in front of you, and I would highly encourage you to follow along in a text editor of your choice, either now or by pausing the video, going back later. I think that will really help to build the kind of intuition and almost muscle memory for how these disparate parts of Rust are wired together. Much more so than just cloning a Git repository and running some code. So definitely do that if you can. Now, this is an intermediate course for Rust, so I'm assuming that you've gone through, let's say, the Rust official book, or at least played with Rust a little to get familiar with its main concepts. So I won't be covering a lot of the very basic concepts, but there will still be a lot of running commentary as we go through and write code to understand why certain things are being done. So I'm using CLion with the Rust plugin. I like this environment. It's very nice, provides some auto completion of code, a good debugger, and some other tooling. But feel free to use whatever editor or IDE you prefer. So I've gone ahead and I've created a brand new binary application. You can see we've got all of the usual sample files, example files that is produced typically from a cargo new -- bin. And so we're going to be building on top of this. Now, what we're going to be building towards is a fully fledged GraphQL server. So it's going to do everything that we expect of GraphQL. We're going to be able to fire off queries, mutations to update data, subscriptions to get streaming data back to our client. We're ultimately going to be hooking up a database, figuring out how to validate input, tackling more advanced topics such as the n+1 problem and things like that. So we're going to be building towards that. But in this first video, I'd like to start with the absolute minimum piece that we need to build on top of. And that's going to be a web server, a HTTP server, that our GraphQL server is going to be layered on top of. So what this is going to do, first of all, is just allow us to fire off requests, get back a simple response to know that the server is alive and we've got something to build on. So if you're coming from a high-level language like, let's say, JavaScript or Python, or even a compiled language, something like .NET, you're probably very familiar with being able to wire up HTTP servers in a couple of lines of code, hook it up to an endpoint, and get things spinning. And so in this example, you may find it's a little bit labored initially, understanding some of the concepts. You'll see we're bringing in traits. We're having to do various different things with setting up our endpoints and configuring the web server. But all of that will pay off. Bear with me as we put this together, because what we're going to be rewarded with at the end of it is a very high performance web server that's going to be capable of handling our production grade traffic and compiling down to native machine code that's going to be highly performant and very safe. Okay, so let's dive in. First thing I'm going to do is head over to Cargo Toml, and we're going to think about some of the dependencies we might need for this project. So as I mentioned, this is going to be built on top of a web library, and the one we're going to be using for that is Warp. Warp I've chosen because it's a first-class integration for the async GraphQL library that we're going to be using to build the actual GraphQL server pieces. But also it has good support for WebSockets that we're going to be relying on heavily for subscriptions to provide streaming data back to the client. So there are various different integrations. Some of them are a little bit easier to get to grips with. This is one that I'm familiar with, and again, has that WebSocket support. Not all of them do. So I recommend checking that out first of all. So we'll head over to Chrome and crates.io, and I'll just grab the latest warp. And you can see serve the web at warp speeds. This is built on top of Hyper. Again, not the most easy web library to configure. If you're looking at something like Rocket, for example, a little bit friendlier in some cases, but it is something that's kind of set and forget. Once we've built this, you don't really have to think about it too much, so it's also quite nice. So another library, a couple of libraries I'm going to add in, support for logging. Okay, so this is just going to give us, oh, if I type this properly, This is just going to give us some nice console messages when things happen. So when the server boots up, or there are any problems, or it's handling traffic, that kind of thing. So the first thing I'd look at is heading back to Chrome, is the log facade library. Now this is a common one. This is used often, and we're going to pull this in scope in such a way that other parts of our application, other libraries like Warp that rely on log, if available, are going to activate those features. Okay, so all we need to do is bring in the log library. And another one I'd like is the pretty end logger, which just kind of augments log and provides us with these nice colorful messages just to make things a little bit nicer. So I'll go ahead and I'll copy paste those in. And so another piece that we're going to need for running the web library Warp as well as async GraphQL is an async runtime. We're going to be doing a lot of async stuff, a lot of asynchronous functionality, and so this needs to run within a runtime. Rust doesn't come with one when you first fire up Rust. You need to provide that mechanism to access and run asynchronous functionality. So the one we're going to be using for that is a popular one within the Rust ecosystem called Tokyo. And what I'm going to do is just grab that, much the same as we have the other couple of packages. But this time, rather than copy and paste in the main installation here, we don't want the default features out the box. We want all of the features because we're going to be reliant on a few of them. And rather than having to kind of cherry pick the ones that we want, we'll just keep things simple and pull in all the full feature set. Okay, now we're building a very minimal web endpoint just to almost serve as like an alive check to make sure that the server's online. And so typically I would send back responses to a client in JSON. That way it's very easy to parse. It's not then just for human consumption. If we have some kind of tooling, we want to programmatically check whether the server's alive, we can actually read those responses back. So we're going to add in a little bit of serialization that allows us to do that. And for that, I'm going to be using the Serde JSON library. Okay, so Serde, very popular serialization library that can serialize to a bunch of different formats. JSON is, as the name suggests, just the JSON piece of that. So we're going to bring that in to scope as well. And with all those in, that should be good enough now to build on. So let's jump over to our main RS and start writing some code. Okay, so at this point, when I'm thinking of the application, I'm trying to think in terms of domains. What are the pieces of the application? What are the distinct pieces, which may have some overlap? So these pieces may fit together in various different ways, but what are the domains of the application? So we're building a web server, so I think it's safe to say at this point that we probably want a submodule. We'll call it server to keep things simple. And this is going to be distinct from any later pieces where we're building our GraphQL schema. So I'll start by creating that new Rust file. I'll call this server mod. And mod, of course, is a special file name within Rust that calls this out as a module. And CLine provides this convenience where we can attach it to the parent scope. So in this case, mod server has been added to our main RS to bring that into scope, make it available to our main application. Okay, so what do we actually want in here? So we want this endpoint. So we'll kind of work backwards. We'll think of the result we want. We want an endpoint that's going to give us some kind of JSON payload. So we'll start by defining that piece first. So I'm going to create a new file here, and I'll call that roots. That's what we're building. We're building roots, and we're attaching a file, this particular file there, to the mod RS. So again, this kind of brings it into scope. In this case, to the server scope. And so we want to build this endpoint. So we'll call this health. That's exactly what it is. It's a health check. And it needs to return something that Warp understands and can interpret as something that needs to be sent back to the client. Okay, so in order to do that, what we're going to do is return this result object. So this is just the standard result that comes from Rust. And if it's an okay result, we know everything is good. If it's an error type, then Warp can do its thing and display an error back, whether that's an internal server error or something like that. So it has to return something that Warp is familiar with. And so what the thing it's going to return, if it's in a good state, is something that implements this reply type. And this comes from Warp reply, you can see. And again, this is a convenience within CLine, so I've just clicked that and it's brought that in. In some editors, you may need to type this manually. And if things go wrong, it's going to return something called a rejection. Okay, so we've got this Warp rejection reply. Okay, and this is going to be an asynchronous function. This is an asynchronous web library. So we'll say here, just to annotate what this is, so we'll say check that the server is alive. Okay, so what are we going to return back? Let's keep things simple. Simple JSON payload is going to have an OK key, and that's just going to be true in all cases. So nothing could really go wrong with this. It's not like we're reaching out to a database and the network could go down or our credentials could be wrong or anything like that. So in all cases, this is going to be okay, what we're returning. And now we want to tell it that this is going to be a JSON response. So I'm going to start typing JSON, and you can see C-line has picked up here that there's this type available warp reply JSON, this function, this method, and this is what's going to tell warp that we're dealing with a JSON payload. So add in all relevant headers, the content type, and all that kind of stuff that it needs to do. Okay, so that's good. And now we need to provide something that could be translated back to that OK true message. So for this, I'm going to bring in Serde, and I'm going to bring in the JSON macro. Okay, so I'll put this up here. I'll say Serde JSON, and we're going to bring in this JSON macro. And we can hover over this in CLion to get some help. So you can see what it takes is basically an arbitrary, almost anonymous struct looking thing that it's going to turn into a Serde value. That's something that can be serialized. And if we jump back a step and look at what JSON takes, it takes something, this T, where T implements serialize. Well, that's exactly what this JSON macro is going to give us. So rather than having to define a struct with an OK bool and define those types, we can keep this anonymous by using this this JSON macro. Okay, so we'll define that as if we're in JavaScript land, and this is just a simple JSON. And you can see we get the red squigglies there because it's expecting a reference type. It's found a value. Okay, so all we need to do there is just return the reference, and then everything appears to be good, and we're good. So up here, we just also need to get rid of this exclamation mark. When we're importing macros, we don't physically import the exclamation, the bang character there. So we can leave that out. Right, so now we've got this simple route, and what we need to do now is just wire that up to warp in such a way that it mounts to an endpoint. So I want this to return whenever anybody goes to the host and port name that I want this to be spawned on. So the root, if you like. And so what we need to do now is just build something where it tells warp that we want to do that. So let's create this function that we're going to call make routes. And we're going to add on this in later videos. So we're going to compose these routes together. So ultimately, we're going to have a GraphQL endpoint. We're going to have a playground as well, where we can fire off queries and subscription queries as well and get streaming data back. But for now, this just has our health route. So what is that going to return? It needs to return the type that Warp understands is essentially a configuration for routing. Now, as you'll see in just a second, some of the types when we're composing these routes together can get a little bit gnarly, a little bit long. So we don't want to define that as the kind of full configuration because we don't really know what that's going to be yet. Instead, Warp provides us with this boxed filter type. And what that is basically a way to tell Warp, look, we've got this configuration of routing. We don't know exactly what it is. It's stored on the heap. We don't really know the shape and full size of it. We've got a pointer to this thing, and it basically does everything that we want it to. Okay, so in order to implement that, we need to add this implementation of reply. And so basically what this is going to say is that whatever the routes are, the handlers that provide the routing, they are going to implement this reply method. And as you see up here in our health endpoint that we've got handling this this JSON payload, that's exactly what that implements to. Okay, so we've got everything we need there. And what we want to do is define our route and the mounting point in the application. So I'll call this health. So this is going to shadow in the variable up there, but we're not going to need that after this point. So that's cool. And what we're going to say is warp. We want you to mount this to a path. So this is warp path. And this is going to be the end path. Now, if we hover over this and see what end is, you can see it matches the end of a route. So basically, it's the / in the route. It's right at the root of the web server. And so we don't need to define a particular path for that. We just want to be able to hit that directly. So end is good. And once a user a client has hit that endpoint in our HTTP server, and then that means we want to route that through our health method or our function up here. Okay, so I mentioned that the types can get a little bit gnarly if we use C-Lion's introspection there. We can see already this is implementing a crazy bunch of stuff. So it's implementing a filter, which is of all these types, which also implements a future, which is going to return an output of implement reply, blah, blah, blah. We don't want all that stuff definitively typed here. So instead, what we want to do at the moment, because we've got a single health point, endpoint, we just want to borrow, sorry, we don't want to borrow that, we want to box that. So basically what we're saying is take this thing and provide it as a boxed filter so that we don't really know what's in there. We're going to leave that for you to figure out. We're just going to store that on the heap. We don't know the size. It's not going to go on the stack. And you'll see that currently this is in red because we haven't brought in the trait that adds in this box functionality. So if I option enter on in C-Lion, again, this may be different for different IDEs and editors, we can import the type there that it's found, which I think was warp filter or one of these up here. Yeah, so we're good. And you can see now everything looks like it's going to compile. Okay, so one more thing we need to do is just add this public modifier here, just to say, look, we want to bring this into scope, and we don't want to make this public everywhere. It's only relevant within our server mod. So what I'll do is I'll add the super keyword there that's going to scope it here, so we can use this within this main piece, this main module. Okay, so now what we want to do is basically take that root configuration and spawn a server. So how do we do that? Well, let's also create an async functionality here, async function. Let's call this start. Okay, so this is going to fire up the web server. So what we want to do is we want to run warp serve, and this is going to create the server, and it's going to listen in on an address, and we're going to provide it the configuration it needs now in order to mount that endpoint. So where's it going to get the endpoint from? Well, roots as before, and this time we're running make roots because it's going to then return the root configuration, and we actually want to run then the server. And so if we hover over run, you can see what it's requiring here is something that implements into socket address. So what is that? Well, this is just an address because Warp needs to know the IP, the local IP to run this on, as well as the port to listen on for client requests so it can serve on that port. So we need to provide it an address. Now we haven't given an address anywhere at this point. So let's actually take this in start. So we'll say address, and again, we'll copy the same thing. So this is just going to implement the into socket address. So why is it into socket address and not just socket address? Because this could be any type that is convertible into a socket address. So you'll see in just a moment when we edit main and we provide that definitive IP and port, that this is basically going to take something and turn it into a socket address if it knows how to do that. And this could be a variety of different formats. The one we're going to use is a combination of an IP address and a port. So we're going to just put that in. Just trust me on this for now, and you'll see how that's wired up in just a second. And we're going to await on it. So this looks like it does everything we need. We'll just add a little bit of doc commentary there. We'll just say that this starts the API server. Okay, so this should be good enough to run. So if we jump back to our main, all we need to do at this point is wire up what we already have. So I will start the API server down here. We'll just get rid of this this sample hello world message, and I'll just say what we're doing. So start the API server to handle requests. That's exactly what we're going to be doing. And so we've already got this mod server, so we'll just bring that in. And I think we actually need to make this public. So if we jump back to our mod, yeah, so we'll just say pub here, just so that could be brought into scope. And we'll say start. And again, this is something that implements a socket address that we need to provide to it. Okay, so this is going to be a tuple. And what I'm going to do for the first part is just provide our IP address. So this is just going to be the local loopback interface, just so it can spawn my local machine. And I'll, for the second part, provide the port. So 3030 common port, could be 8000, 9000, something like that. 3030 will work For this particular case, I've got no other services running on that port, and we want to be able to put a wait on that. This is just basically going to run forever. Okay, so if you're following along and if you've done any Rust asynchronous programming before, you'll already see a problem here. So we're in basically a standard main function. This is the entry point to the application, but I'm using this await keyword in order to execute this, schedule this awaited function. Now we're not within an asynchronous runtime at this point. So how do we get that? Well, remember we pulled in Tokyo, and we've got this this convenient annotation that we can add to this function called Tokyo main. If we hover over that, I don't think we actually do get helpers in annotations at the moment in C-line, never mind. In any case, what that does is it takes our code that we provide here, and by the way, we can turn this into an asynchronous main function now. It takes this, it spawns the executor, the Tokyo asynchronous runtime. It handles the scheduling of our asynchronous method, and it does all that stuff for us just by providing this annotation. So it's a convenience basically to turn this from a plain vanilla main into an asynchronous main. Okay, so that's good enough now to fire up our application. Well, the one last touch that we may want to add is just a little bit of logging so that this fires up and we actually know something's happened. Because at the moment, if we run this, we'll just get kind of a hanging cursor in the terminal. We won't know that anything's happened. So in order to bring in login, what I'll do is I'll use this extern create log statement. And what extern does is it brings a library into scope where it's expected in other libraries. So it basically says, hey, look, we've got this external thing available to us. If you're looking for this thing, then feel free, go ahead and use it. Okay, and we'll do the same thing with extern create, and we've got this pretty end logger just to make things look a little bit nicer. Okay, so I'll initialize the logger. That's exactly what I'm going to do here. And this is the only line we need at this point in order to bring things in, and Warp will be looking for that login package if it's available. If it is, it will leverage it, it will use it, it will fire some console messages back to the screen. Okay, that should be good to go. So if we head over to the terminal, what I'm going to do is I'm going to fire that up with a cargo run, but you'll notice I provided this environment variable rust log debug. That just sets the log level for the log facade to use. So Warp, for example, is going to show us everything that's debug level and above, which is basically everything we need. I'll go ahead and I'll fire that up. Now this will take a little bit of time, so I'm going to pause the video here. Rust, notoriously long compile times, unfortunately, but it does get a little bit quicker once we've compiled some of the basics. So I'll just pause that, and I'll see you in a sec when we're running. Okay, we are back, and you can see we have this message down here that the server is running. If we scroll up, you'll see I've got this unused import. If you'll remember, I typed borrow instead of box a little bit earlier, so I can get rid of that if I want to, but it doesn't affect the application. It's just a warning. So we'll leave that alone for now. I'll clean that up later, and what I'll do is I'll just grab this, this server address, and we'll head over, open a new tab, I'll fire that up. And there's our OK true. And if we move this over to the right, you can see if we hit refresh on that, we get the full debug messages. Okay, so not too interesting at this point. The very, very minimal basics, and possibly a little more labored, a little more explicit than you might be used to in some other languages. We're already bringing in traits, having to have types that implement other types and all this kind of stuff. But again, once this is wired up, we very rarely have to touch it. So we know we've got a highly performant, type-safe, natively compiled piece of code here. So this is going to be a good foundation to build on. So let's do exactly that. Let's head over to the next video at your convenience, and we'll start layering in some of the GraphQL pieces and spicing things up.